Hello children, welcome back to the third video of electricity chapter. In this video we are going to learn about heating effect of electric current, Joule's law of heating and electrical power. So let us proceed for the next bit, that is heating effect of electric current. So when electricity passes through a high resistance wire like nichrome, the resistance wire becomes very hot and produces heat. This is called as heating effect of electric current. Children, whenever you take a wire, suppose there is a wire, okay, whenever, or a conductor you can say, whenever there is a lot of resistance inside it, means if there are many obstructions inside it because of collisions, what happens? Because of that collisions, their heat starts developing in that conductor. This heat, it is mainly by the resistance of the conductor. So we call it as heating effect of electric current. The current, whenever the current is flowing inside that high resistance wire, because of heavy collisions, we get heat is developed in that conductor. This effect we call it as a heating effect of electric current, children. Okay. Now it was being found by discovered by James Prescott Joule. He was a English physicist and brewer. And Joule studied the nature of heat and discovered the relationship to mechanical work. So how work is done, he has discovered that one. Okay, this led to the law of conservation of energy. How the conservation of, what does it law of conservation of energy says? Energy can neither be created and nor destroyed, but can be converted from one form of energy to another form of energy. So this relationship was discovered only when he discovered the relationship to mechanical work, and this led to the development of first law of thermodynamics. Thermodynamics, it is a branch of physics which deals with the study of heat. Okay, now SI unit of heat was given, energy was given as it was named after this scientist, which is called as Joule. Okay, the SI unit of heat is joules only, right? Now he worked with the Lord Kelvin to develop the absolute scale of temperature. Lord Kelvin, you know, who has discovered the scale of temperature, how to measure the temperature. And Joule also made observations of magnetostrictions, and he found the relationship between the current through a resistor and a heat dispatched. Means when a resistance, if it is having more resistance, how that heat is developed, which is now called as Joule's first law. Okay, let us study about Joule's law of heating. What does it say? Joule's law of heating says that if electric current I flows through a resistor having resistance equal to R, means if there is a resistance equal to R, the potential difference through the resistor is V, the charge Q flows through the circuit for the time T, thus the work done in moving charge Q, it is given by potential difference V, it is equal to V into Q. W it is equal to, you can say, we have already studied one formula, that is we have studied W it is equal to V by Q, right? V, or you can say not W, it is equal to V by Q. So we have already studied voltage formula, V it is equal to W by Q, work done upon unit positive charge. While studying about the potential difference, we have studied that V was equal to W by Q. And from this only we can say that work done can be written as, okay, V it is equal to W by Q, work done can be written as W it is equal to V into Q. So this is what we are going to write, V into Q now. Whatever the work done is there, it is being given by V into Q. Now using this V into Q, we are going to find out what? So work done per unit time is rate of consumption of energy, that is called as power. So what is power? A rate of consumption of energy, means per unit time how much energy is being consumed. So work done by time, it will give you V into Q by time, means work done, it is given by V into Q and it is given divided by time. When you divide this V into Q by time, so V will remain as it is. Q by T, we know a relationship, Q by T is equal to I, we know I it is equal to Q by T, we have studied in the first video that current was equal to Q by T. Now we are going to substitute, in place of Q by T, we are going to substitute I there, so which results in, so we are going to write it as P, W by T was resulting in power, and V into Q by T was giving V into I. In place of Q by T, we are just replacing V into I. That's what we have written here. So that is called as power. Power means rate of consumption of energy, you can say. Okay, now using this principle, now Joule also stated that when you want to some energy should be developed, okay, the power should be supplied for certain amount of time. So when you give power into time, means for when power is supplied for certain amount of time, that will result in heat, generation of heat. Example, suppose now if you are just what you call switch, if you switch on a bulb, okay, if you switch on a bulb for certain time, okay, so will it get immediately heated up? You might have seen many a times when the bulb it is being burned for a longer time, it gets heated up. But what if you just switch it on and off for in a limited time, will it get heated up? No, answer will be no, because it will not get heated up as soon as we switch it on, but it will take some time to get heated up. Similarly, if you take any devices which works on the principle of this, so to get heated up it takes some time, current should flow through it and power should be consumed in that. So power into time will give you this one, energy. Okay, so energy, heat energy you can say. So powers, we are having a formula, power it is given by Vi, and just you are multiplying into, in place of power we are writing Vi, and time we are keeping it as it is, and this will give one more formula to find out the heat energy formula. So it is given by VIT. Power into time will give you what you call energy. Energy is also given by VIT. Now if we replace this I, okay, in terms of V and R, we know by Ohm's law we are having V by R, I equals to V by R. If you substitute in place of I V by R, it will be equal to V we are keeping as it is, in place of I we are going to keep V by R over there. Okay, if you just keep V by R over there, okay, I'll just take it now, V by R we are going to keep, and time we are going to write as it is, and that will give you energy. Now that will become V square by R into T. Okay, V square by R into T. This will become one more formula to calculate heat energy, you can say. It is also given by E as well as H. Okay, so now I'll just erase it all, and now just as we have taken VIT, it is equal to heat energy. Okay, and instead of that, instead of placing I, we have kept V square, V by R, instead that become V square by R into T. It is also becoming the formula of heat. Now we will just replace this value of V by IR, because V equals to IR by Ohm's law it is we are having, and we are just placing VIT, it is equal to heat energy, and we are going to place in place of VIR, I will just put it IR into I, we will just keep it as it is, and into T we will just keep it as it is. Now this I into I will become I square, and R it is left, and T it will become heat. Now this law is going to become the Joule's law of heating. Okay, I square RT will become Joule's law of heating. How? What does it Joule's law of heating say? What does it conclude? So we'll just study it now. So Joule's law of heating says the heat produced in wire is directly proportional to the square of the current. So what is saying? So heat is directly proportional to the square of the current. You can say heat is directly proportional to the H, it is directly proportional to the square of the current. First thing it says, because each we have seen that I square RT it was, okay, heat was directly proportional to the square, means heat is depending on how much current you are going to supply. Okay, so how much current you are going to supply, it is depending on that one. Okay, the heat is depending on the amount of current you are going to supply. Then heat is also depending on resistance of the wire. You can see here R, heat is directly proportional to the resistance of the conductor. Means as you just connect, means as you increase the resistance of the conductor, heat is developed, more heat is developed. So heat is also dependent on directly proportional to the resistance of the conductor. Third is time for which the current is passes. Means so heat is also depending on the amount, for the time, how much time you are going to supply the current in that conductor. So heat is also depending on time period. So these are the three factors you can say on which the heat is developed, or heat is proportional, you can say heat is produced. Okay, these are the three things which on which the heat is depending. Okay, if they ask you what is Joule's law of heating, you are going to write this one. Joule's law of heating says that heat produced in a wire is directly proportional to the square of the current, resistance of the wire, and third, time for which the current is passed. Okay, so next thing which comes is the applications of heating effect of electric current. What does this application of heating effect of electric current say? So there are many practical applications, uses of heating effect of electric current. So mostly are as follows. So you may be seen that in an incandescent lamp the bulb glows. Okay, you might have seen a 60 watt bulb or 100 watt bulb. The filament inside that it gets heated up and it glows. That is one of the application. In electrical stoves we are developing heat for the cooking of food. Okay, so same as soldering the irons, you can see what I've seen. Okay, soldering, for soldering purpose to connecting the wires, we are heating it up and we are melting the metal and just we are fixing it. And electrical fuses, in our electrical fuse which is mainly connected in our house. So when there is excess flow of current, what happens? This fuse gets melted up because of heat. What happens? Heat produced, it gets melted up and this breaks the circuit, because of which all the electrical appliances at home, domestic electrical appliances will be safe. Okay, so electric fuse is also one of the most important. And nowadays people are using electronic cigarettes, hookahs and vaporizers, and all the things that they are using electronic only. Okay, thermistors we are using, and you might have seen in electrical iron also we are using this property. Okay, thermostats and all we are using this one. Okay, these are some applications of heating effect of electric current. Okay, these are the few applications. You might have found many other, you can write that one also. Okay, so let us go for the last bit of it, that is electric energy. You can see we have found that heat was equal to I square RT, gives the rate at which the electric energy is dispatched or dissipated, consumes an electric current. So we have just stated it. What is power? Electrical power is given by rate of consumption of energy, or at which the energy is being consumed, that is called as power. So power is a rate of consumption of energy. So SI unit of power is watts, you can say. So you are going to measure the power in watts. SI unit, you are going to remember this one. Power is always measured in watts. You might have heard about the 60 watt, 30 watt, 18 watt, 12 watts. You might have heard about these measurements. See, it is the power rating, you can see. So SI unit of electrical power, it is watt, and the power consumption of a device carries 1 ampere of current when operated on a potential difference of 1 volt. Means, see, you can see that here you can see voltage into current means 1 volt per ampere. This will give you 1 watt. Okay, 1 volt, 1 ampere will give you 1 watt of the current. So next is, so what is the value of 1 kilowatt hour? So you are going to measure the values in 1 kilowatt hour. Kilowatt hour means 1 kilo means 1000 watts, and hour means into 3600 seconds. If you multiply, that will become the 1 kilowatt hour value, that is 3.6 into 10 raised to 6 watt seconds, or you can say joules. Watt seconds is nothing but joules, heat energy. So heat is measured in kilowatt hours or in joules. Okay, kilowatt hours when we are measuring in commercial units. Whenever you are measuring the home bills, electrical bills are always in kilowatt hours. Okay, this is all about theoretical part, all about the electricity chapter. Okay, this completes the electrical chapter, children. Thank you.